Okay, we have already one cumulative physical chemistry revision in less than 1 hour. Okay, physical chemistry revision in less than 1 hour through the DPP. Okay, already we have one, but now it is a second step to revise complete physical chemistry through the cumulative practice DPP. Okay, now, this many people after the immediately chapter, if some advanced questions are given, they are able to solve because they don't have the switching problem. Okay. So when 5 to 6 chapter together they are given, then they are not able to recollect the sums or formulas or concepts. Okay. For them, this will be the best thing. So let's start with the first question. Okay. So here the section 1 total marks are 61 marks as per the advanced pattern, and section 1 again multiple correct answer. Okay. So this is a physical chemistry, complete physical chemistry. We are going to revise with the short tricks. Okay. Short tricks and complete detailed explanation so that not only same question, similar pattern question you will be able to answer. Okay. So which is oblique RR irreversible process, irreversible process. It is just a common sense question. Once you mix the two gases, you cannot separate them. So it is irreversible. Here see, temperature plays a vital role. Water boiling point is 373 at 1 atm. So it is equilibrium only. Water at boiling point definition is the temperature at which solid and liquid boiling point definition is the temperature at which liquid and gas coexist. So it is a reversible. If suppose in the next exam they give 380, then that will be reversible. Only this temperature plays a vital role. At this 373 only, it is reversible. Okay. Next one, dissolution of NaCl in water. Once we form NaCl at but that point of time, at that temperature, we cannot recollect the or we can regenerate the NaCl. Then ice melting again same 273, 0 degree and 180. Because of this, it is reversible. So A and C are irreversible process. Okay. Now let's see the next question. Okay, if same quantity of electricity passed through electrolytic cell containing, listen very carefully, theory questions are more dangerous according to me, okay? Because if full stop is there instead of comma, that meaning will be entirely different, okay? Here what you need to understand, where you have to take care. Here iron is in the form of the +2. Here iron is in the form of the +3. Here iron is in the form of the +3. But these two anion is different, okay? So amount question what you have to then correct, I think. Okay, correct statement we have to find out. Amount of iron deposited in FeSO4 are equal. No. Here it requires 2 electron for 56 grams. Here it requires how many? 3 electron for 56 grams. So it is not equal. Okay, why it is not equal? Is it understood? So that's why I initially pointed out the differences. Okay. Then amount of iron deposited when 1.5 times. Obviously, it is +3 and it is +2. So it will be 1.5 times. Okay. 3 by 2 times. That is 1.5 times. This is correct. Then amount of iron deposited. Here it will be +2. Here it is plus FeNO3. Sorry, here it is +3. Here also it is +3. So oxidation number is same. So iron also deposited will be same. Therefore, it is also correct. Same amount of gas. See here, all the three cases at anode. Here, first sulfate ion is there. Second, a sulfate ion is there. Okay. And third also nitrate ion. Now, they are actually not participating. Who will participate? OH minus will participate and oxygen will be liberated. Once gas is same electricity is given, so quantity of the gas collected also will be same. So B, C, D are correct, A is incorrect. Okay. Then in empty cylinder, piston arrangement, N2, NO2 and N2O4. Same question we have solved, but as a numerical we have solved. Okay. During the explanation of the derivation formula, we have formula derivation, capital D minus small d, n minus 1 upon small d. This derivation itself I told during that this variation of density, variation of moles, always I told you n greater than 1 during the decomposition. Okay. So if you go through that numerical already solved, then this is not a numerical basically. It is a theory question based upon that numerical. Okay. So here density of sample will decrease, obviously decrease because moles are increasing. Moles increasing, temperature same, therefore volume will increase, but mass of the gas is same, so density will decrease. Okay. But with the derivation, I have explained that if you are satisfied with this explanation, need not to go through that, otherwise you can go. And NO2, this is in P block. P block NO2 is reddish brown color gas due to presence of one unpaired electron. So when reaction proceeds, more NO2 will be produced, more will be the deeper color. Okay. So that's why the A and C options are correct. Is it understood? Okay, this numerical also better go through that explained already, but here it is a theory question. Okay, now let's go on to the next slide. Next slide is about the very important on this specially states of matter and chemical kinetics and surface chemistry. These are the chapters where you should be able to convert the sentences or equation into the graph form. Here it is given P into V minus B is equal to RT. So they want to maintain a graph isochoric, volume is constant, and that means it is a graph between pressure and temperature. Okay. So we need to have pressure and temperature. So V, I will send it that side. P is equal to R by V minus B into T. So when you compare it with y is equal to mx, x-axis temperature, y-axis pressure, slope is equal to r by v minus b. Therefore, it is absolutely correct. There is no intercept. Okay. Now next, let us see the second. Okay. Isobaric curves Vt have slope of r by p and intercept of b. So here we want v value. So we cannot neglect that multiplying this in this formula. After multiplying this inside, pv minus pb is equal to rt. All of you concentrate on explanation. After that you can note down. So PV is equal to PB sent that side, RT plus PB, V is equal to RTP cross multiplied. Now it is in the form of the, so it is in the form of what? Y is equal to mx plus c. See here, I am comparing y is equal to mx plus c. In place of c we have b. In place of slope we have r by p. See, this is what he is saying, slope is r by p, intercept is b. Then compressibility factor, simply you have to same as I have done here, same you have to derive for the equation PV by RT. Then you will get 1 plus PB by RT. Okay. And here there is a special term. Attractive forces are overcome by repulsive forces. When I gone through this question, I was also in wrong impression that attractive forces are more, but again myself thought in a piece. Okay, in examination heat this will be taken as I have thought it in the initial thought. Okay, here it says that repulsive forces are more than the attraction forces. So when repulsion forces are more, then Z will be greater than 1. Okay, so that's why this question mark I created itself, so that I wanted to enumerate during the explanation. Okay. Now let's see the next one. See, parallel reaction. Parallel reaction, I think we have done in the numerical session of the parallel reaction. There are parallel reaction, sequential reaction, and consecutive reaction. Okay, with these derivations also given, the one of the derivation is going to be utilized here. But as a formula we are using here. But how that came, that you can go through the derivation session. Okay, so A gives K1 and K2. So, but here it is given first order reaction. Okay. Now, rate of formation of B will be 3K1, 3K1, okay? 3 here from the coefficient, rate of reaction, rate constant is K1. Concentration of B at any time will be 3K1. At the same time, concentration of C will be 2K2, okay? So here K1 is already given. Here K1 is given as how much? 10 to the power of minus 3. K2 is already given 2 into 10 to the power of minus 3. So it will be 3 by 4. What is the answer? Concentration ratio of concentration of B and C will be 3 by 4. But see here, not correct. What you have to select? Not correct. Okay. See here, after rigorous practice, we are saying that 3 by 4. And this idiot says that it is 1:2. Is it correct or incorrect? Incorrect. But you have to select incorrect answer only. Okay. Sometimes it happens. We have to go for the incorrect options. Okay. We have no options in the life. Next. After infinite times of total moles between 2 to 3. Okay. See here. Initially 1 mole. When the reaction is completely happening in the C part, it will be 2 moles. When the reaction is completely happening towards the B, then 3 moles. But it is partly going towards the 3, partly going towards the 2. Therefore, it will be 2 to 3. Is it clear to all of you? There is no derivation for this. You can understand. When A proceeds only in the C direction, moles of the product will be only 2. When A proceeds in the B direction, the moles produced will be only 3. But it is going in the either direction, so it will be between 2 to 3. And here this derivation is there. T half of the parallel reaction is equal to 0.693 by K1 plus K2. K1 equal to 1 into 10 to the power of minus 3. K2 is equal to 2 into 10 to the power of minus 3. Therefore, total value will be 3 into 10 to the power of minus 3. Okay. So 0.693 divided by, this is what? K1 by K2. Okay. And how much time they want? 0.693. So number of half-lives in the 693 will be total time divided by 1 half-lifetime. Okay. So this will be 3 half-lives. 3 half-lives means 1 by 2 to the power of 3. So that means 1 by 8. It is absolutely correct. But we cannot select. Why? Because question is not to select the correct answer. You have to select the wrong answer. Okay. At some time, concentration of A, B, and C all will be same. Never will same. If one molecule goes in the C, it will produce 2 moles, and B will be 3 moles. So it can never be same, because 3:4 will be maintained at all times of the reaction. Okay. Okay, next, concentration, similar to very excellent question. Okay, this is the which came favorite question. Here, deriving the formula. Why I am favorite of this question is deriving the new formula, understanding the old formula. And the beauty of this question, where is our stamp? The lovely sentence is defined as volume of the gases evolved. Okay, volume of the gases. Very favorite. Okay, so why it is favorite, that I will tell you, and during the explanation you will understand that. Okay, here normally H2O2, in the derivation of H2O2, what we will see? H2O plus O2. Okay, and balancing 2 H2O plus O2. So this is the volume we will take. But here you should not take this volume. You should take all volumes. What you should take? You should take all volumes. Okay. So here, what are the gases? Your vision should be sometimes at the bottom, at the bottom, at the bottom. Now, don't worry about the water. Okay. Complete universe is how much? I think it is 2/3 of the earth is covered with water. So here you need not to worry about the water. You should worry about the gas. Okay. So only gas works sometimes. Here, according to this equation, volume strength is given how much? 212.8. Okay. So if you balance this and at STP, whatever the we measure, that will be at STP. Okay. Here balanced equation, you can see 4 moles. Okay. So if I am using 4 moles, I will get 6 moles of nitrogen gas, 12 moles of carbon dioxide gas, 1 mole of oxygen gas. So total moles collected will be how much? 6 plus 2, well, 18, 19 moles. Okay. So if I use 4 moles of what you call nitroglycerin, I will get 19 into 22.4 liter. So 4 molarity stands for 22.4 into 19 liter. But how much it is there? How much it is there? 212.8. Then if you find out the molarity, it will be 212.8 divided by 19 into 22.4 into 4. Then you will get answer as a 2. So the molarity of the glycerin will be 2. How much it will be? Molarity of the glycerin will be 2. So, and this, there is a shortcut I told you, converting mass, molarity into mass. Okay. So if you convert, then you will get to 454. Otherwise, simply here, 227 2 ja. 227 2 ja 454. And it is the mass percentage. And the mass percentage, you will have the shortcut. What is the shortcut? I think you know, into 10, density, mass percentage into density into 10 divided by molecular mass. If you do that, then you will get 41.27. So as per me, I am getting C answer. You may get some other answer. You can cross check after this lecture. Okay, make proper notes. Next, numerical type. Okay, we have switched from the section 1 to section 2, where you will be discussing the integer type questions. Integer type questions. Okay, lengthy questions, so have patience. Kp is given. What is given? Kp. Okay, Kp means equilibrium constant in terms of pressure, not somebody's shortcut. Okay, one person is there whose shortcut name is Kp. Okay, so 2NO plus Cl2 gives 2NoCl. Then the flask contains NO at zero point 0.02 atm. Millimoles of Cl2 you have to find out. Okay. See here at the between, in the sentence between, he is asking the question. After that, all information. Okay. So millimoles of Cl2 must be added 1% of NO to be converted to NoCl at the equilibrium. Okay. So first let us write the Kp formula. Kp is equal to PNoCl, product of, okay, sorry, to the power of 2 divided by PNO2 to the power of 2 into PCl2. Now I have substituted all pressures and all. How I have substituted? I have substituted like this. Pressure initially, how much it is? 0.02. That time there is no NoCl. This value not given. For the time being, I am taking it as a X. Then 1% of NO is converted. So this will be minus 0.02 1% of NO. This will be produced. So 0 plus 0.02 into 1 upon 100. And this must be added. Okay, so X plus P, but our intention is to find out P first. So final P if I find, then X we will find out afterwards. Okay. So that is already I have written here. So after substituting the given values, P value of the NOCl I have substituted here. Kp is already given. How much it is? 10 to the power of, where it will come like this, like this, like this. Yes. Kp is equal to 10 to the power of minus 3. PNO is how much? The 0.02. 0.02 minus 0.02 into 100. That will be PNO2. Okay. So after simplifying pressure of Cl2, you will get it as a 0.1202. But it is not answer. Okay. Here something already reacted. Something already reacted. That plus P. Actually here it should be X plus P. Okay. So something already reacted, how you will come to know? It will be half of the NO. 2 moles if it is reacted, 1 mole Cl2. So this is the half of the NO. Okay. Sorry, this answer is from here. This is the half of NO. Then total value will be in the range. Okay. In the range of 20.40 to 20.403. Okay, I hope all of you will do this question specially. Afterwards, if any correction is there, kindly let me know. Always good answers are welcome. Next, let us to move to the next integer type question. Okay. Here, the key points where you have to be very careful are already circled. Disproportionation. Which nation? Disproportionation. Okay. So where our copper is oxidizing to +2, oxidizing to what? +2, and reducing to Cu plus. Okay. Here it is oxidation. Here it is reduction. But our intention is to find out the Cu plus 2. For that, what we have added? Ki we have added. Then it will convert to the Cui2 and K will be separated. So again it will reduce back in the original state Cui plus iodine. Now this iodine is measured. It is iodine is measured. See, I2 is expelled. Then iodine is measured with the Na2S2O3. Okay. So this is what the paragraph is given. This is the Angrezi given in the paragraph. Okay. So that Angrezi is already explained. Now here mass is given. Mass need to be converted to millimoles. So for moles you will divide with the molecular mass. It is 166 into milli. For the milli I have multiplied with 1000. So millimoles of iodine we already have in the starting. After the reaction here this is 50. Okay. Then how much of the Ki consumed is equal to millimoles of Na2S2O3 used. Iodine is identified by using the Na2S2O3. How much it is used? 10 ml into 1 normality. So millimoles of Na2O3 and iodine both will be same and it is 10. So initially we have how much? 50. And how much it is converted into iodine? 40 left over. Okay. Now 40 divided by this is moles. Sorry, equivalents, milli equivalent. So mole will be 20. So from molarity formula, if you calculate, then you will get the mass of the copper. It is how much? 2.86. How you will find out? I think understood. Millimoles equal to mass upon atomic mass or molecular mass into 1000. Then you will get 2.86. Question is how much of the copper cuprous oxide is available in the 3 grams of sample. Out of 3 grams, only 2.86 was the original Cu2O. Rest all are just mixed. Okay. So this is about the answer, and 2.86 divided by 3 into 100. I am getting 95.33. You may get something else. So reply with the correct answer if it is other than this. Next. Okay, estimate the cell potential of Daniell cell in millivolt, milli. 1 molarity of zinc and originally 1 molarity of Cu after sufficient ammonia. This is one of the dangerous, I think in the mains, advanced electrochemistry DPP, we have discussed change in conductivity complex formation. Here, this is the reason. Okay, here it is the explanation. So, when Cu2 plus added with ammonia, the complex formation will take place. What will take place? Complex. See here, number of ions are different. Here, ammonia is there to conduct and Cu2 plus, but all are converted into only 1 mole. So this will change the conductivity. Okay. So Kf you have to find out. What you have to find out? Kf you have to find out. Okay, Kf is equal to 10 to the power of 12. How I could come to know? I could come to know because it is given here 10 to the power of 12. Okay, so product upon reactant. This is the product and depending on the reactant. All values given are substituted. Okay, then you find the Cu2 plus in the solution. How much it is? 6.25 into 10 to the power of minus 14. Okay. Now, with the help of this, we can find out the E cell. E cell is equal to cathode minus anode. See, here zinc electrode potential is oxidation potential. How cruel he is. See here. Oxidation potentials are given. Actually, its reduction potential will be minus 0.76 and reduction potential. So this will be anode, this will be cathode. So cathode minus anode, you will get E naught cell as a 1.1. Okay. Some years back, I got it as a 1.1. I don't know what it will come today. Okay, so 0.059 upon 2 into log product upon reactants. Okay, here reactant one concentration is already one. Copper concentration you will substitute here. Then you find out E cell. E cell is equal to 0.71 volt. Okay, 0.71. Okay, but when you convert into millivolt, it will be 710.60. Answer will be 71.60. Okay. Okay. Next, two buffer. Very fascinating question. One buffer is not sufficient. He is taking two buffers. One buffer of 4 and another buffer of 6. And started mixing them. Okay. So, and both buffer concentration of acid is same 0.50. What would be the pH of substance or solution are adding mixed equal volumes? Very simple. See, this is the first buffer equation. Okay. And second buffer equation will be same, but here it will be 6 and in concentration of base conjugate base. Okay, we don't know, that is what we want to find out. Okay, so one you take it as a x, another you can take it as a y. So add all of them. Here acid is common to both of them. Acid is common to both of them. So divided by whatever answer you will get, like here you will get 0.05 is the concentration of conjugate base in the first, conjugate concentration of conjugate base in the second. Okay, it is when it is 5, pH is equal to 6, conjugate as base concentration is 0.5. Conjugate as base in the first one is 0.05. So again you will substitute equal volumes. Concentration will be half of that. Then you will get the pH as 5.70. First equation, by using the pH of 4 we have taken and found the concentration of salt. By taking the pH 6 we have found the concentration of salt. Then again substituting in the another formula, but this time we will find out the pH. So same formula is to be used 3 times. First for 4, first for 6, second for 6, third for finding out and substituting the concentration. Then you will get 5.70. Okay. Now let's see the next. Decomposition of N2O5. Decomposition of N2O5 according to the equation 2N2O5 gives 4NO2 plus O2. Okay. Here I will tell you the procedure but I doubt about these values. Okay, so simplify and tell me the answer is 0.32 or not. Okay, so listen carefully. If you are able to write this equation, 2N2O5 is 4NO2 plus O2. If I take A moles, this will be 0, 0 because it is initial. Okay. If A minus X, here for 2 moles I am taking as X, then 4 moles it will be 2X. For 2 moles if it is X, then 1 mole will be X by 2. Okay. But problem is that he has not given anything initially. Okay. In good olden days, they used to give initial and final, but he has given two intermediate times. This is at t 10 minutes. This is the final. Okay, complete decomposition. So complete decomposition. So NO2, N2O5 will be 0, and whatever we have taken A, it will be 2A because 4NO2. And it is A, it will be A by 2 when complete decomposition is taking place. So final pressure will be directly proportional to A, P naught. Understood? Initially, only A is there, so P naught. Therefore, we will find out P naught in terms of the A and X. So, total pressure is how much after 10 minutes? A minus X plus 2x plus x by 2 is equal to, that time pressure is how much? See here, I think 289.5 it should be. You can cross check either 289.5 or 289.1. Okay. Then second, we will form the same equation. Here the total 2a plus a by 2. How much it is? 5a by 2. So it should be 590. Now it is correct. Okay. So a is equal to 2 into 590 by 5. Understood? So we got both A and A minus X. Then what you will find out using the first order kinetics. K is equal to 2.303 by T into log. In place of A, you will write this value. 2 into 590 by 5 divided by, in place of A minus X, you will write 289.5. Then you will get the final answer. K, you will get it. Okay. Here you will find it as a T is equal to how much? 10 minutes. In place of A minus X, how much it will be? 289.5. The denominator. In place of A, you will write 2 into 590.5 divided by 5. Okay. Next, find the number of diffusion steps. The formula, I hope, okay. So here, this is the formula. Number of diffusion steps required to separate isotopic mixture. Actually, see here, this is called as an enriching factor. We have studied, but that time we have studied as a enriching factor. How many times? Suppose two gases are there, A and B. So if it is A is lighter one and B is heavier one. So once first diffusion is there, this will diffuse fast. So the leftover quantity of B will be increased, A will be decreased. Again diffuse, A will be keep on decreasing, B will be increasing. So number of times if you keep on doing, we will increase the concentration of B. At the same time, we will decrease the concentration of A. That is called as a enriching factor. Here same thing, whatever I have taken A, they have taken as a they have taken as a D2 and B they have taken as a H2. So they want that H2 collected should be 4 times as compared to D2. D being heavier one, it will remain in the original container. And hydrogen being faster, it will move and collected in the final container 4 times. So to achieve this ratio, we are not purifying, we are enriching one of the isotope. Okay. So here I will consider this is 24.6. Okay. So total pressure it is given, total volume it is given, total temperature it is given. So this will be, by using this, we can find out the total molar ratio. Here 1 mole of D2 is there, but H2 we don't know. NH2 plus 1 is equal to PV is equal to nRT. PV is equal to nRT. So N is equal to PV by RT. So pressure is given as 24.6, temperature is given as 300 divided by R is 0.0821, T is 300. So now with this you will find out the number of moles of H2. So initially they are available as 2:1. Initially they are available as 2:1. We want them to convert into 1:4. Okay. So for that it will be N value you have to find out by substituting in this formula. What is 4 here? Molecular mass. Simple rate of diffusion is equal to square root of molecular mass of A divided by B. Here A molecular mass is 4, B molecular mass is 2 hydrogen, and initial ratio is how much? 2:1. Finally, we want, this is mass value. Okay. So finally, we want 1/4. You can directly write it as a 1/4 also. Then on simplifying, N value will get 4. That means if it is diffused, enriched 4 times, we will get 1/4 ratio. Okay. Note down this formula, and after that, you can go through the theory lecture. Okay. Next one. Okay, next one, 2 grams of sample containing, 2 grams of sample containing NaCl and NaBr. Here, this is also, I think, previous question. I remember once I explained, but not of this batch, I think. NaCl and NaBr, inert impurity. See here. NaCl is also there, NaBr also there, impurity. Total mass is how much? 2 gram. So out of that, I am taking NaCl as a X and NaBr as a Y. So inert quantity will be 2 minus X plus Y. 2 minus what? X plus Y. Okay. So here our X grams is there. See here, already I think you have studied in practical organic chemistry. There is a practical organic chemistry, percentage of carbon in CO2. Suppose you have to find out percentage of carbon in CO2, what you will write? X divided by 12 into 44. What is this? Mass of the carbon divided by 44. What is 44 here? Mass. Okay, carbon dioxide molecular mass. Like that, similarly we are using here. What is the change here? It is NaCl. Sodium mass we are interested. So sodium mass, let us take X. X divided by 58.5. What is 58.5? NaCl molecular mass into 143.5. Okay, what is 143.5? 143.5 is the total when it is converted into AgCl. AgCl molecular mass is how much? 143.5. Okay. So this much grams of NaCl converted to this much grams of AgCl. Okay. See, I will write it clearly so that further formula can be understood. NaCl is converted to AgCl. So this is 58.5 grams converted to 143.5. So X gram converted to how much? So X by 58.5 into 143. Okay. So this is the mass of the NaCl converted to AgCl. Same way, if you apply to the AgBr, Y by, here NaBr mass. What is this? NaBr. NaBr sodium will be 23, bromine will be 80. So total value will be 103. Okay, and it is converted to AgBr. So AgBr is 108 plus 80, 188. So this is the ratio. Yeah. Now, how much it is? 3 grams of precipitate was formed. Total mass is how much? 3 grams. So, but after shaking it with aqueous NaBr, that means something is eliminated. Okay, whatever the AG's BR, NaBr, AgBr formed. AgBr formed is how much? X upon 585, whatever the X, it is subtracted from already formed. Then it is given as 0.7476. This is already formed, it is washed with aqueous NaBr. Then you will find out the X value. X value is 0.9828. Now, If in what you want percentage of NaCl, X mass is how much? NaCl only we require, so X is the mass of the NaCl, 0.9828. Total mass of the sample is 2 grams. So 0.9828 divided by 2 into 100. So you will get 49.14. Okay. Okay, next is rock salt. In rock salt, the sodium and chlorine. Chlorine forms the lattice, FCC lattice. Okay, here B minus forms the FCC lattice. And sodium occupies body center. Here in place of the sodium, what they have taken A, where it will occupy body center plus edge center. So this information you know, you should know. Okay. Now here Z value is how much? 4. So A plus occupying octahedral void. Octahedral void means edge centers and body center. Now it is doped with atoms of C, which occupies all tetrahedral voids. So, but due to defect, body center atom is missing. So initially they have how many? Four atoms, but due to body center defect, one is missing. So number of effective number of A will be 3. Okay, and B will be same, no problem, because they are forming the FCC. Number of B4, how we got, is it understood? And if lattice points are 4, FCC will be how many? 8. Sorry, tetrahedral voids will be 8. Okay, so 8 tetrahedral voids, and A will be 3, B will be 4. Okay, now see here, this is the corner, this is the corner. Okay, corner, who is available? Who is available at the corner? B. Okay, and here tetrahedral words, these are the tetrahedral words, C, and edge center, sorry, body center is missing. Body center is missing. So this total length in terms of A is equal to root 3A. Edge length, sorry, body diagonal. Okay, but occupied by C here, one radius of B, one radius of B, 2 RB. Radius of C how many? 4 RC. How many RC? 4 RC. So substituting here, and root 3A, root 3A is a body diagonal, but edge length is what? Edge length we can consider in terms of the B also, in terms of the B also. So if we consider in terms of the B, it will be 4 RB. Okay, so if I divide this, see here, 2 RB by 4 RB, 2 by 2 will get cancelled, 1 by 2, plus 4 RC by 4 RB, so RC by RB. Okay, so this will be the RC by RB. 1 by 2 is 0.5. See here, RC by RB. There is a one word. This word plays a vital role and provokes me to take 0.225. Ideal radius ratio of tetrahedral void will be 0.225. So already 0.5 is there. 0.225 is the voids ratio. Therefore, it will be 0.725. So answer will be 0.725. Okay. Afterwards, you can again practice it in peace time. Okay. Okay. Next one is same question, similar type we have done in the advanced electrochemistry assignment. Okay. So spontaneous of a cell, how you will find out? By simply finding out the E cell. Okay, E cell, if it is positive, then it will be spontaneous. EMF of the cell will be 0 only when either both concentration is 0 or standard EMF. Concentration of cationic decreases up to equilibrium. So this is a concentration cell. Okay, so once equilibrium is 0, that means E cell must be 0. So once E cell is equal to E naught cell. The same way standard EMF of cell is 0. This will not depend on the concentration. See here it is a simple concentration cell. So standard EMF will always be 0. Then concentration of Cl minus, here only one place you are finding the Cl minus. So this is the answer. So for P, what is the P here? This one. It will be, first option is correct because see, lower concentration is anode, higher concentration is cathode. Therefore, spontaneous. P will be spontaneous. Okay. At the same time, EMF of cell is not 0 because concentration is not same. So 2 is not an option for P. And concentration of cation decreases up to equilibrium. Here, this will increase and this will decrease. Then only we will get the equilibrium. Then the cell will stop working. Okay. Then standard EMF of cell is 0. So P answer is 134. P answer is 134. So options B or D may be there. Further you compare only Q. If you get fourth answer, then answer will be D. If you don't get fourth answer, answer will be B. Okay. So Q is concentration cell as well as pressure cell. Okay. So HCl common, but anode is hydrogen, cathode is chlorine. Okay. So Q answer will be only one. What is that? Spontaneous. Because anode is 0.014 cannot be 0. Standard EMF cannot be 0 because hydrogen is not there here. Chlorine is there. So our obvious answer will be B option. Okay. Why B option? How to approach without checking all other options? I think it is clear to you. Now next, see here is the formula from which this is derived. Actually, this is a beyond scope. Only once this type of question arose in our advance, but that time lot of controversies are there. Okay. So from here, this question, this is a formula. Okay, note down this question formula very carefully. Psi r is equal to k into n minus l minus 1. Degree of polynomial will be how much? N minus l minus 1 into r to the power of 1 e to the power of zr upon n a naught 0. Okay, and here it is given k3 is equal to 1. How much it is given? K3 is equal to 1. Okay. So according to K3 is equal to 1, if you substitute here, you will get L is equal to 0. So L is equal to 0 means it is S subshell. Okay, L is equal to 0, it means S subshell. And when you find out N value, it will be 3. It will be how much? 3. So it is regarding the 3S. Okay. So once you get the 3S, all these values can be found easily. Okay. Now let's go to the next one. See here, very easy question, but if you understand it concept wise, okay. Here graphite is converting into CO2. Graphite is elementary form. For the carbon, graphite is elementary form. Both reactants are in elementary state and forming CO2. Therefore, it is formation. Okay. So 1 is equal, P is equal to formation. Why it is formation? Formation of CO2. It is the enthalpy of formation of CO2. And we can also say it is a enthalpy of combustion of graphite. So 1 and 2. Okay, P will be 1 and 2. Atomization, atoms are not manufactured. Sublimation means solid is not converted to gas. So P answer will be what? Only 1 comma 2. But terminology is different. It is enthalpy of combustion of what? Graphite. Okay, enthalpy of formation of CO2. Okay, so P answer will be 1 comma 2, and we have only one place 1 comma 2. But in graphite converted to gas, see, graphite converted to gas, solid converted to gas, therefore sublimation. In gas there is no bonds, so atomization. Therefore, and it is also called as a formation. Elementary form is converted to substance. So 2, 3, 4. That means likewise you can compare all other options also. It will be 1 2 2 3 4 1 comma 3. Okay. Now let's see the next part. Okay, next part is very easy question, but if you study the polyprotic graph, okay, this I have given special